All right, this is an investigation example on the properties of the normal curve. It's from our textbook. So in this investigation, we're going to look at some of the interesting properties of the normal distribution curve with help of this graphing software. So we're going to click on this icon to explore the normal distribution curve and how it changes when we change the mean and the standard deviation. So this demonstration shows the normal probability distribution. Use the sliders to vary the mean and the standard deviation to watch what happens to the shape. So what I'm going to do is I'm going to change the mean to 0 and have my standard deviation stay as 1. So this is our mean, our average. So the average of our data set is at 0. And then here is our bell curve. Now I'm going to adjust that average to 1. I'm going to run it to 2. Notice that mean is moved along the x-axis. We can also go in the negative direction. There's the average, and the average moved. Now let's see what happens when we do our standard deviation. As we increase our standard deviation, watch what happens to the curve. If we go smaller than 1, so what happens when we move the mean to the right? It's just going to move that average to the right. We move it to the left, it's going to move that average to the left. Now, as we go smaller, as our standard deviation gets smaller, what happens is all these data points run closer to the mean, the average. They're more closer.
Matthew Ritchie, please come to the front door of the building. Matthew Ritchie, please come to the front of the building. Thank you.
All right. As we increase our standard deviation number, our data points are more spread out and farther away from the mean, from the average. So, what effects do the variations in the mean and the standard deviation have on the curve? Go ahead and think to yourself. Does the curve have that line of symmetry? Yes, it's symmetric about the mean. Is the function ever negative? Down below here, no. Discuss the behavior of the normal curve as x gets larger and smaller. So it's starting to become 0 and become 0. What do you think happens to the area under the curve as you change the mean and the standard deviation? So as we change it this way, not seeing a difference in the distance. Now see how high it gets. So from this investigation, we did talk about this in a previous video. We have that line of symmetry about the mean. The function's values are greater than x, and the x-axis right here is that horizontal asymptote underneath the curve.